topics. The first one will be actually, before we get started, I just want to say, like, you can find the material. I'm going to be basically reading from a README, which contains from this repository that's linked in the RStats Google Sheet. And it has like a README that I'll be going through, as well as the scripts that we'll be talking about. But in terms of the topics, I'll be covering like what I call nested array jobs, and then also this idea of like a run all script, which I'll get into. So sort of two different topics for today. So in terms of like our packages we'll be using today, we'll touch on the Slurm jobs package that you can install from GitHub. Otherwise, it'll be mostly like sort of like bash, like shell scripting and stuff. So yeah, I guess we can just jump in. So before we talk about like nesting array jobs, obviously it makes sense to talk about, just to do a recap. For some people it would be recap, some people may be new, just ordinary array jobs with Slurm. So the idea behind like an array job, like an ordinary array job, is that usually if you have a data set with like multiple samples, or a data set that you can break apart where you want to apply the same sort of processing on multiple data points, that's like a natural use case for array jobs. So I'm just going to jump into an example. So basically, if you have a shell script that you are going to submit with sbash to Slurm, the way that you make it into an array job is just with this one line. Just in here, we're saying that we want to have 3 tasks, 1 through 3, and that we want to run all 3 at once. And so in this, I think in this particular use case, this was a case where I had a 3 sample data set, and I was trying to find spatially variable genes, tool called in an SVG. So the way this works is, we have 3 different tasks, like I said, and this shell script will get executed 3 times. And the only really difference is the Slurm array task ID environment variable. So that'll be 1 in the first task, 2 in the second, and 3 in the third. And then typically we'll have since we do a lot of analysis, we'll have this shell script will actually invoke the main analysis that we'll be doing inside R. So just to go to that. And then, so here, I'm not going to get into the details of what the script is doing, other than it's finding spatially variable genes. But the way it's actually using this array job is we have a bunch of sample IDs. We're taking the available sample IDs that we have for this data set, and then we're reading in this environment variable, the task ID. So that's either going to, like I said, it's either going to be 1, 2, or 3, depending on which task is executing. And so basically we're running the script 3 times with different samples. So that's the core concept behind an ordinary array. And there's lots of benefits to this. Like, for example, parallelism is built in. I would say if you can make an array job rather than using, there's also options for using parallelism in R. But if you can use an array job, that's almost always going to be better, because it's called like embarrassing parallelism, where you get to actually get a full linear speed up in terms of like the actual amount of time it's going to take. So that's the idea behind basic array jobs. And then we'll get to more complicated cases, where what I'm going to be talking about today is like this idea of nesting. So basically in that example I gave, we were just looping through samples. So looping through one categorical variable. So like nesting, this has come up recently in analyses that I've done, where I actually wanted to loop over multiple categorical variables. So like one example is, this is actually basically the example I just ran into, where I was trying to do a form of clustering, and I had multiple tissue samples, but I also wanted to use multiple settings for the clustering. So multiple values of K, and a clustering that was based on finding K clusters. So that's basically, if we wanted to make this into a loop, we want to loop over samples and values of K. So there's a couple ways to do this with array jobs. So one of them, I'll be presenting 2 different options. The first one is actually you can sort of submit an array job that other array job. So it's like you're using like a nested call to sbatch. So in this, I'm just gonna go to some of these links I have. So in this repository, you can find the examples I have here. So actually, let me go to the most recent version, most recent commit here. So we have all the scripts. But basically these 3 scripts here, the O1 scripts, are going to be covering this example using a nested sbatch call. And the idea is you have this outer wrapper script. So I'm going to go into this right now. And you submit it like a normal job. The only thing it's going to be doing is going to be invoking other jobs. So by itself, you don't, I mean, you really only need a minimal amount of memory and a minimal amount of time as well, because it's just calling sbatch, which is pretty instantaneous. The next thing it does is actually, in terms of the log file, the wrapper itself is not going to generate a log file itself. So if you're not familiar, in Linux, there's a file called /dev/null. And essentially, if you redirect output to this file, it's as if you're it's almost like a trash bin. It doesn't go anywhere. And so this is one way that you can say, like, I don't actually want any output from this file. And in this example case, we're pretending that we're doing clustering with different k values. Let's say we have values 2 through 10. So this outer array job is looping through these values of k, and let's say we'll do 2 at a time. So the way this works is that, like, you first sort of define the outer task ID. So there's 2 loops. There's an outer and an inner loop. We're talking about the outer one right now, but we're just taking the array task ID from the outer loop. Then the log file for the inner loop is the one that we really care about, and it's going to be composed of the value of k right here. And then also there's a Slurm specific syntax, parentheses A, which says use the task ID of an array. So once we actually submit that to the inner loop, that %A will turn into the task ID from the inner loop, which I'll get to. And in order to pass environment variables from into a job that you're sbatching, you have to use this export syntax. And so we're exporting this outer task ID into the inner loop. And then the main script that we want to submit is this inner loop. So I'll go to what that looks like. In our inner loop, let's say we have a 4 sample data set. So we use an array that has 4 different elements, and we'll do 4 at once. And by the way, from the outer loop, we're doing 2 tasks at once. And in the inner loop, we're doing 4 tasks at once. That's a way of saying that you actually want to do 8 at once. So it's a little bit awkward in this format to say the exact jobs you want to do, but basically you're just multiplying the inner and outer tasks. So in this inner loop, this is the one that we actually use to execute the script of interest. In this case, I'm actually using a Python script as an example. And so basically we're looping through 4 samples and then multiple values of k for a hypothetical clustering example. So in terms of what the Python script looks like, the Python script is using the tasks. So it's a very basic example. So the first thing we do is we import the task ID from the inner and outer loop. So this is in Python, this is the typical way that you would grab an environment variable. So Slurm array task ID is actually the inner task ID. And then we have that variable that we've already defined for the outer one. Then we're just converting it into an integer. And then the way you might use this downstream is that if you have like a data set with 4 samples, you can define the 4 samples up front and then use the task ID that you've pulled in to subset to the actual sample of interest that you want to be running on this particular task. And the next thing is, like, if we used values of k is already an integer, and that's kind of how we can just directly use the outer task ID. So I'm not actually going to show an example of doing clustering, but I'll show I'll show actually executing this. And we're just basically proving that we actually did import we're accessing the correct sample and the correct value of k that's going to be unique for each task. So I'm going to go ahead and actually run this. So I have this repository clones locally. I've changed directory into the directory with these scripts. And so to invoke this, you invoke this wrapper outer loop script. It's going to go, actually, let me make sure I'm in it wasn't auto completing for some reason. So you just submit that with sbatch. I'm going to try to observe this, like, these tasks are going to go by quickly, but let me see if I can quickly. I should have maybe made this name a little bit longer, but to show you what's going on. So I have some other tests going on, but we're running this main loop. And here you can sort of see it's going to be executing some of the inner loop tasks and then the outer loop. So it's a little bit complicated to observe in terms of the actual jobs that are going on, but it should complete pretty quickly. I'm just going to give it a little bit more time. So I think we had 9 tasks on the outside and 4 on the inside. So it's really executing 36 different little tasks. Still, some of these jobs are completing. And yeah, so these log paths, like I said, were going to be under this logs directory and then names by the value of k in the sample. Just give it a few more seconds here. And by the way, feel free to interrupt if you have questions, because some of this stuff is certain parts of it can be complicated and introducing it kind of quickly. Okay, I think that I'm actually not sure if the log file completes when its jobs are in this completion status, but I think they are probably ready. I'm going to reload, and now we have 36 different logs over here. So we have, like, for example, the first one, we're clustering sample A, who we just had letters for our sample names and values at k equals 2. So yeah, we have the k value and the sample name in the log name. So obviously, if I go through a different one, sample B, K2, or down here, sample A, K4. So that's one way to do nesting. I'll talk about some of the advantages and disadvantages of this approach after I introduce the other one. So yeah, you can actually nest your SVetch call. Sort of a more general solution that I've briefly introduced it actually in another RStats session is you can use the Slurm jobs package. There's a function called job loop, and this sort of works with any number of loops. So the example I gave was like actually really only works with 2. So that's one downside. I mean, I find that often in practice, the most common situations you'll run into are like 1 or 2 loops. I think it's more rare to have more than 2, but it is possible with this option. So in R, if we were trying to make a script like this, we would load the Slurm jobs package. So here's the actual R code you'd use. And then you can actually make basically a nested array like this. You just give it a name for both the shell script, and it also creates an R script, which I'll get into. And then you give it the loops. So just like our above example, we have values of K. And the current implementation, I may end up changing this, but it has to be character values for now, but that doesn't really interfere with the way it works. Just convert the numbers to characters. And then of course we have our 4 samples from before. And so you just give it a list with however many loops you have. We only have 2 here, but like I said, you can have 10 if you wanted. You could have a bunch. And then the rest are just sort of options that aren't really relevant for the actual array, just setting the memory. Then this create shell option actually writes the shell and the script to disk. And so what that looks like, go to here. So these O2 scripts here were created with job loop. And so there's an R script and a shell script. We'll just go into the shell script first. So the difference with this approach is that it's actually one big array job. No matter how many loops you have, it's a single shell script and a single array. So instead of doing a loop where we have 9 tasks and a loop where we have 4, this is one loop with 36. And there's some tricks here. Like, again, we're redirecting the output from this to dev null. So, but actually down here, we're using a task, our custom log path that has the name of the K value and the sample ID. So that's useful when you have you want to actually have the names of things in the log rather than the numbers. So like the first example I gave was you just have the numbers in the log path. And the difference with this approach is it's using a combination of division and modulus division to subset each variable. So it's finding the value of K by sort of the algorithm computes the correct division equation to use to find the appropriate value of K of all the ones that you listed. And then similarly with the sample ID, it's using a different expression. And again, of course, each of these will be unique. And so to actually use this, the task it's really doing is it's calling this R script, and then it's passing each of your loop variables via the command line. And then in R, it's using the getopt package to import those 2 variables. And then it automatically will print what the values of the variables. And then in here, you would normally fill in the actual code for clustering if that's what we were doing. And so I'm just gonna clear these logs out just so we can see what it looks like to execute this O2 script instead. And that's gonna run pretty quickly as well. It's only doing 20 at a time, but it should still be only a couple of seconds for each task. Any questions so far? Anything that I didn't explain well or could be clear? Okay, so.
Just a question, Nick.
Yeah.
I think that this package is really helpful. I use it almost daily. So I have always try to think what is the best way to define the number of jobs that you have to trigger at once.
Yeah.
Most of the time I'm just guessing. So
Mhm.
how many of these jobs have to be submitted, or if there is a kind of formula to, to define it in appropriate way? So if you have some ideas about it?
Yeah, I guess there's like two considerations. So like JHPCE, there's the shared queue or shared partition. And so, I mean, there are hard limits on like you can use up to a terabyte of RAM and 100 cores if that hasn't changed since last time I remember. And so, I mean, that limit is going to be like, even if you tried to you could try yourself to run 1,000 tasks or something, and it's just not going to let you. So you could either rely on JHPCE's limits, or I tend to like, if you also have access to like a private partition like Catan in our group, I try to like not use, I have to remind myself of how many CPUs and like memory we have, but I try to not use like all of it. So that can be just like estimating like maybe not more than several hundred gigs of memory and maybe not more than like 20 or
Okay.
30 cores. Maybe it's really dependent. Like if we do have the resources to like, I guess some of that is like an art, like trying to not use too much, but also parallelize well. So I
Okay.
don't know if I have an exact formula, but yeah, those are the things I think about, I guess.
Okay. Okay. Thank you, Luis.
Okay, so these it's finished. We should have the logs. And so, yeah, similarly, we have the value of K2 for this task, sample A, and then it's in the actual array, it's the 36th task. So yeah, we print this variable. So it did indeed work. And that's all we did. But I guess something else I can show for something that makes maybe this approach, one advantage of this approach is, so we print the job ID in this by default in these logs. So if you just grab the job ID from any of these logs and load R, and then you can use Slurm jobs. You can just in a variable. I'm bad with my variable names sometimes, but you can use the job port function and input that task ID in a data frame. It gives you a bunch of things. So this is what I always use when I have an array with a bunch of tasks. Instead of like checking, I mean, in theory, you could try to check all the logs to see if there's errors, and there might be a way to automate this, but I think the easiest way is just using this function. And then you could even do something like table A, and then there's a status variable. And we see that all 36 of the tasks completed. So this is like a really automated way to just check if everything worked. And then if for some reason something didn't complete, you could filter to the status that was like not completed, and then grab the array task ID, which is also a variable in this data frame. So that's just in case you didn't know about that. That's something I use all the time. And so, okay, so I've introduced both those approaches. And so I guess I also want to do like a little brief comparison of like, I think there's use cases for both. In terms of like the script readability, something I didn't mention is that like the nested SBatch might be a little bit better, just because in the job loop option, I don't know if there's really a way around this in terms of coding changes, but basically, right, it's going to actually list out every single option. So if you had like a loop, if you're trying to loop through like 1,000 things, this would not be super practical to list 1,000. I mean, I guess it's not going to like break probably, but it's less readable, I guess, if you had 1,000 different elements here. So that's like maybe one slight argument for using the nested SBatch. Something I've noticed, I don't know if there's really a way to improve this in the job loop function, but this nested SBatch is a little bit more modular. So like say if we go back to this script, let's just say we don't care about, we want to do different values of K. So we did 2 through 10, but like now actually I realize I want to find more clusters. So I could just go like 15 through 25 or something. And then I want to run the same samples through. So that's pretty straightforward with this, but it's actually not so simple to change here because we have a single array that's trying to do a combination of loops. So this is maybe less modular in terms of editing a single loop if you're trying to do a subset of tasks. So that is something I ran into, and like maybe I sometimes end up just redoing the whole array, which is like not super efficient when I'm using job loop. So that's one consideration. The nested SBatch also requires like more than one script, which you might not like, as opposed to job loop, which is one, no matter how many loops you have. And like I mentioned, nested SBatch is always 2 loops. There may be an approach to do more than 2. The approach I use currently is not going to work for more than two. But again, job loop, you can use any number of loops. So that's a lot more general. So yeah, those are some ideas that hopefully inspire you to try this with your own analyses. So if there's not more questions, I'll move on to the next topic. But yeah, so next topic is a little bit unrelated, but I guess it also has to do with sort of Slurm and running analyses at JHPCE. So I thought of this idea just recently because I had to create like this run all script for one of my projects. So just to introduce a topic, I mean, this is a topic in like Leo's group, but if you're not familiar, when we have a project associated with a Git repository, usually that repository has a bunch of analysis scripts. And so we like to write what's called a run all script. So that's a shell script associated with the project or repository. And the idea is that it contains like every analysis step in the project. So we do that for a couple of reasons. One, it's like serves as documentation for how to do the analysis for that project. And it sort of forces you to be organized about which your series of steps that you're doing. And then the other function is that it's actually going to submit, or it has code to submit the analysis steps. So in a project where we learn something new about the data or the goals change, it's a way to sort of resubmit things in an automated, hands-off way. So you don't have to wait for tasks. If you want to, okay, I guess without a run all script, you might submit one job and then the workday ends and then maybe the job finishes at midnight or something. But you have to wait until the next day to resubmit it. And so when there's a huge number of scripts in your project, that can be like not super efficient. So this is like a hands-off way to resubmit a bunch of analysis steps and have them automatically like start without you having to monitor it. So we actually have like a template Git repository for Labor Institute. And in that project, there's an example of one of these scripts. So typically we give it like a bunch of the SBatch options because in theory, you can SBatch this entire thing, but it has a couple of things in here. So in this case, we only have a few different. There's actually only 3 scripts because it's a small example, but we have like this one script where we're reading in data. We have another one where it does some plotting and then some more plotting. So there's really 3 scripts here. And it's using, I guess one concept here is, I mean, Cynthia did a nice RStats club on this, but this is using job dependencies. So we first grabbed the ID from the first analysis step, and then we pass this to the next submission of the second script, where we're saying after this finishes with an exit status of 0. In other words, if it succeeded, we want to run this second script. And so you can put a bunch of these in series, and I'll show another example soon. But so I guess the trick here is that like with a small example, it's easy to sort of put things in a linear order, like have a bunch of steps sequentially. But I wanted to I guess I was running into the project I was working on. I had a more complex sort of design where it definitely wasn't linear, and there's a bunch of different side analyses and stuff like that. But yet we wanted to be able to use a run all script for its benefits of like documentation and then allowing resubmission. So I just want to give like a couple of recommendations that might be helpful for you. In general, I mean, in this README here, I'm sort of describing, you can describe a workflow in like as a mathematical structure, as a directed acyclic graph. The math isn't super important, but the idea is that really you can form a diagram where you have analysis steps and then you connect them with the edges on one of these graphs represents the flow of data. So if you have a project, I think this was helpful for me. I just try to think about it from a high level and then sort of summarize the major analysis steps into units. So you might describe these units as like data preparation, quality control, and clustering. And that might involve a lot more scripts than just those 3 things that I mentioned. But just as a starting point, I think it can be useful to sort of summarize the high level steps. And then you can draw a diagram. So this is what worked for me. In a project I was working on that actually had a lot going on, but I summarized it in terms of these steps. So this was a spatial project. So we had run Space Ranger. And then there were sort of 2 different steps that were related to clustering. And we were building a spatial experiment object along the way for one of them, and then doing some spatial registration. So this is how I summarize like a project I was working on. And then once you have that sort of in place, the next step is you can sort of just number them. I mean, it's not a linear order, but you can just kind of like top to bottom, left to right, just 1, 2, 3, 4, 5 here. And then I guess I should mention that if it gets like extremely complicated, maybe like you could consider something like Nextflow or SnakeMake for like, those are really designed for much more complicated workflows where you just want to define the inputs and outputs for each step and then let the graph sort of form itself. But so that's just like a little side note. But I think most of the time we won't be using these tools. So yeah, once you've defined your high level concepts and you've numbered them, you can do something like this example here, where maybe we've done, actually, I'll just go into the other example where following this diagram here with the 5 steps. That's not the right thing. It should be somewhere over here. So typically with these run all scripts, a small amount of memory because it's just submitting jobs and also a small amount of time. And a little trick here is that I use this line of code. It's kind of like it's like a git command. I like it because it's sort of like the here package in R, where no matter where you are within a Git repository, it gets the top level. It finds the top level, and then you can use paths relative to that top level. So it really is analogous to here in R for bash scripts. But besides that, once we have these scripts, these high-level steps numbered, I just made little sections and comments. This is section 1, section 2, 3, and 4. So yeah, once you define the high-level steps, then it's a matter of figuring out which jobs go in a linear sequence within those steps, which is usually more straightforward, especially if you've numbered your scripts like we tend to do. So again, we're using that for the first job in the series. We're just using this syntax to grab the job ID, and then after that, we're using this dependency to grab the job before it. And then one way you can keep this organized is you can use a variable name that has like the high level step number, which is the first one, and then the lower level step number. So we have like 6 different lower level steps for this first high level step. And that can make it easier to sort of insert things into your workflow. So that's a general idea. I mean, that's something that's worked for me, even in a more complicated project. I guess another thing to consider is that it's probably rare that you're going to actually submit this script to run every single step in the project. So something you can consider to make this maybe more modular is that since we've divided this into another one of the benefits of dividing these into high-level steps is that you can sort of separate them. And so if we go down here into one of the if we just wanted to resume from this clustering step, we could sort of remove this dependency line here. And so disconnecting it from the earlier parts of the workflow, and then maybe just execute these lines interactively. And so that's one way to keep it modular. And if you just want to resume from a particular step, that's one of the benefits of having this high-level structure. So that's something that worked for me. And I guess I didn't really explicitly say this, but like try to form the high-level steps such that the sub-steps are in a linear order, if that makes sense. So, because otherwise it gets, I guess, complicated to write each of these series. But yeah, that's just some tips that work for me. I think that's actually it for, yeah, that's all I really had for today. So I don't know if that, any questions or everything makes sense.
Well, just related with the design that you are talking about, Nick, the big one, when you have the script with, let's say, 4 steps.
Yeah, sorry, moving this stuff.
Yeah, that one, what I have been doing with this kind of structure is that indeed, as you say, not all the time we need to run the full pipeline, but just a particular section or some scripts. So what I'm doing is, for example, that in the clustering step, I make another script containing all the steps for the clustering, and I just call here the main script with the clustering, let's say all clustering steps, for example. Then I found that the maintenance in this individual script with all the clustering, let's say 4 or 5 scripts, it's easier to me to keep than try to keep it in a long script. I mean, I know that the design is very difficult, or it's something that needs to think about it. But this is what I'm doing. I mean, just for example, define one main script to the first step, and then another one for the second step. So what I want to to give maintenance, I just open the main script with the specific steps containing, I don't know, 5 or 6 scripts, because I never run, let's say, a script containing all the steps.
Yeah.
But I'm still thinking about it. I mean, it's one of the more difficult things that I have found trying to define this.
Yeah. Yeah, I like that. That's a good idea. Having like in that sense, we could almost have like a run all directory maybe where like each of the steps has its own script that we just submit from the main one. That's a cool idea. That could definitely like in this example, I don't have like it's not huge, but I could definitely see as the number of steps grows, that would be really useful to have.
Yeah, I mean, I start doing like a long list of some kind of sequential step with dependencies, but then I found that I never run all, and sometimes I was not clear even myself of what all the steps is connected with the other step.
Yeah.
I have to rethinking about that, and just one, let's say, one way to solve it. I mean, in the meanwhile, is just to make one script from the corresponding module and give maintenance to that module. Because
Yeah.
some of the modules I never touch it. For some reason, they are, I mean, like let's say the processing steps and all these tasks are regularly just make it once probably. And then when I start to work with the clustering or the special registration and other advanced tasks, I have to think really about the design. Yeah.
Yeah, that makes sense.
But I don't know, just giving ideas. But I mean, it's very, very useful what you are saying, Nick. Thank you.
Yeah, thanks. Yeah, that could definitely clean things up. I think that's a good idea.
Nick, do
Yeah.
you ever use the expand grid function from R?
I'm familiar with it. I've used it a couple times, but not super often.
So like if you just go to R right now and do like expand dot grid open parenthesis, like I don't know, 1 to 5, comma, letters, close parenthesis. What that function does, just do letters in plural, close parenthesis. Yeah, press enter. So this makes all the combinations of like all the possibilities on the first vector and then all the possibilities on the second vector, right? So like here we're gonna see like 5 A's because it's 5 numbers, and then 5 B's, etc. Right. So this could be useful if like the example that you showed at the very beginning, where you were doing 9 times 4, I think, combinations.
Yeah.
That can also be done with like an expand grid where you're saying like I have a single array job with just 36 total options. You just need to know how many total options you have right after doing the expand grid. And so there your task ID will define the row of that expand that grid table that you get where you have.
Sorry, I didn't mean to interrupt. I was just saying, yeah, that's a good idea.
Yeah. So like John Muscelli wrote a blog post about this explaining array jobs a few years ago, maybe 10 years ago now at this point. And he showcased this function for that. So like if you are using both things at once, right? So both variables at once, that's where like this could be useful a bit compared maybe to the other structures. I mean, I guess it's just another option, I guess.
Okay. Yeah, that'd be pretty straightforward in most cases, I think. It's a good idea.
Cool. Yeah. Because here's this modulo 9 thing, right? I don't remember we had that on SG jobs.
No, we didn't. I think it created individual shell scripts and then submitted them.
Mm-hmm.
Yeah.
Cool. Okay. I mean, these are all really nice, fancy tricks. I don't know if you were able to look at email thread on BitHelp. John Muscelli and JHPCE admins were discussing some other options that might be useful for the run all script.
Yeah, I took a look. Yeah.
That just happened this week. I don't know if you have any conclusions that you could draw from that email thread, or you're like, oh, maybe you were already aware of those options. I'm not so sure.
I think to me, it sounded like they were mostly talking about like job dependencies with Slurm. And I think that's sort of how I mean, that was my takeaway from it. It was sort of talking about this like dependency after okay is sort of what I read from that email thread. But yeah.
Yeah. So I guess they have situations where like the job reports that it's okay, but it had actually crashed, that thing.
I think in his case, he was asking about like trying to submit jobs even if they fail, or like there's some more complicated case I thought that he was dealing with.
All right. Cool. Thanks, Nick.